I have been assigned a mission. To accept it, it looks like the password is the square root of 2i. Let's go. To find the square root of 2i, we need complex numbers. To understand complex numbers, we need imaginary numbers. They arise when solving equations like x squared equals -1. You might know that the square of any non-zero real number is positive. That's why we need imaginary numbers to solve x squared equals -1. The simplest imaginary number is I, which is defined as the square root of -1. So I is the solution to our equation x squared equals -1. But we can also have 2i, 3i, and even -1000i. These numbers are the imaginary numbers. We can combine real numbers with imaginary numbers, and this is when we get complex numbers. Complex numbers have a real part a plus an imaginary part bi. Note that real numbers and imaginary numbers are just subsets of complex numbers. Complex numbers have real-life uses in electromagnetics, electrical engineering, fractals, and in analyzing cellular signals. So yes, even your cell phone uses numbers like I. The complex plane contains the complex numbers, with the real numbers on the x-axis and the imaginary numbers on the y-axis. Every complex number has a magnitude, which is its distance from the origin, and an angle from the positive real axis. For example, 2 plus 2i has a magnitude 2 root 2 and an angle 45 degrees. The next step is to understand the square of a number in the complex plane. It turns out that if I square a number, my magnitude squares and my angle doubles. For example, the quantity 2i squared equals -4. In this case, my magnitude goes from 2 to 4, and my angle doubles from 90 degrees to 180 degrees. If we try other examples, the same scenario happens. Pause this video if you would like, and try more examples to convince yourself this really works. Recall that our problem was the square root of 2i. If we define this number as x, then x squared equals 2i. And remember that the magnitude of 2i is 2 and the angle is 90 degrees. So if the magnitude of x squared is 2, then the original magnitude of x must be the square root of 2. And if the angle of x squared is 90 degrees, then the original angle of x must be 45 degrees. So x lies at a point that is square root of 2 away from the origin and an angle of 45 degrees. To find our point's coordinates, we can construct a triangle with what we know. This triangle is a 45, 45, 90 triangle with hypotenuse equal to the square root of 2. Since this is a 45, 45, 90 triangle, the legs are congruent, and we can call that distance z. And we can solve for z using the Pythagorean theorem. We end up getting that z is equal to 1 as the positive solution, so our point is at z plus zi, which is 1 plus I. And that's the answer to the square root of 2i. Not much time left. Let's enter the password quickly so we can accept our mission.